Okay, moving on to 7.2 compound angle formulas. We're going to be getting exposed to a new kind of formula that is used to help us split up or to separate angles and use them accordingly, to be able to use special triangle angles from other angles that are given to us. You can see the additional formulas and the subtraction formulas are straight out of your textbook. It's very straightforward. Sine of a plus b, where a and b are two angles, is the same as sine a cos b plus cos a sine b. The cosine of a plus b is cos a cos b minus sine a sine b. What changes between sine a plus b and sine a minus b is simply the subtraction sign, and the same thing happens for cos a plus b and cos a minus b. Remember, sine a plus b is an addition, whereas sine a minus b becomes subtraction. For cosine, it's the opposite. Cosine of a plus b becomes the two things being subtracted, whereas cosine of a minus b is going to have cos a plus b and sine a plus b being added. So let's get to an example of how to apply this. So the first example we're going to do is we're going to find the exact value, right? That's the important here. The important part of this section is going to be a lot of the questions ask for exact value, meaning you should not be using your calculator to just plug in value. You should be using your special triangles. Find the exact value of cosine of 15 degrees. Now, cosine of 15, or the 15 degrees, can be split into two other angles. What I want to do is I want to use two angles that are special triangle angles. So one triangle is 45, 45, 90, and the second triangle is 60, 30, 90. So I want to use either 45, 30, or 60 to get to 15. Well, there's a lot of different ways. I can do 60 minus 45. I can do uh, 45 minus 30. Okay, there's a lot of different ways to get to 15 degrees. We can choose either of these and just start. So let's go with 45 minus 30. We remember that cosine, instead of 15 degrees, it's going to be 45 minus 30. Now we know that cosine of a minus b is cos a plus cos a cos b plus sine a sine b. In this case would be cosine of a, which is 45, cosine of b, which is 30, and again these are just being multiplied with each other, plus sine of a and sine of b. If I can simplify this, if I can get an answer to this, that will give me an answer to cosine of 15. Now cosine 45, we should all be familiar with this now. It's just 1 over root 2, or root 2 over 2. Cosine of 30 is going to be, if you remember your special triangles, is root 3 over 2. Sine of 45 is again root 2 over 2, and sine of 30 is 1 over 2. Now we can combine these. Root 2 times root 3 is root 6 over 4, plus, this is also over 4, root 2 times 1 is root 2. So to combine these into one fraction, because they already have the common denominator, it would simply be root 6 plus root 2, and this would be the answer to cosine of 15 degrees. Now understand that we could easily have done 60 minus 45 and it would have given us the exact same answer. It's root 6 plus root 2 over 4. This will require some practice because it really does require you to be able to work with radicals. When you have square root functions, how do you combine them? And to figure out how to, in certain situations, rationalize your denominator. Meaning you want to be able to get rid of the radicals or the square root numbers that are in your denominator. Let's go to B. Let's try it again. This time we have a more complex question. Negative 5 pi over 12. If it helps, you can take negative 5 pi over 12 and think of it as degrees. So negative 5 pi over 12 converted into radians would be negative 75 degrees. So again, we're going to use some combination of 60, 45, and 30 and come up with negative 75. So let's think about how we can get negative 75 degrees. It could be negative 45 minus 30. Again, we can come up with a lot of different ways. We haven't really talked about how to use larger angles yet, and we'll leave it for later for now. So negative 45 minus 30 would give you negative 75 degrees. So tan of negative 5 pi over 12 can be written as tan of negative 45, which is negative pi over 4, minus 30 degrees, which is pi over 6. So negative pi over 4 minus pi over 6 would work. And again, we go back to our tan equation for subtracting. Tan A minus tan B over 1 plus tan A tan B. So tan A would be negative pi over 4 minus tan of B, which would be tan of negative pi over 6, all over 1 plus tan A, which is negative pi over 4, times tan B, which is negative pi over 6. Let's figure out what we know. Tan of negative pi over 4, this goes to quadrant 4. In quadrant 4, my answer will be negative, right? So I'm just going to split this up here. So it'll be negative, and then tan of pi over 4 is 1. So that's a negative 1, minus tan of negative pi over 6. Again, negative pi over 6 is quadrant 4, so my answer will be negative. Then tan of pi over 6 will be 1 over root 3. Down here, 1 plus, I already know tan of negative pi over 4 is negative 1, and tan of negative pi over 6 is negative 1 over root 3. Let's keep going. This becomes negative 1 plus 1 over root 3 over 1 plus 1 over root 3. What I am going to do now is I'm going to show you how to convert this value here, okay, the 1 over root 3, and so that it's a proper numerical, so it's a proper number, so it's not a radical, a square root that's in the denominator. So I'm going to multiply the bottom by root 3 and the top by root 3, which means I'm going to do the same thing here, multiply the top and the bottom by root 3. This will turn into, so root 3 at the top, root 3 times root 3 is just 3 at the bottom, and this would be root 3 over 3 as well. Let's keep going. So this would be negative 1 plus root 3 over 3 over positive 1 plus root 3 over 3. So we're going to now go across here and continue to combine. So we're going to combine our fractions. So that's 1. Negative 1 would be negative 3 over 3 plus root 3 over 3 all over 3 over 3 plus root 3 over 3. Put all of this together, we have negative 3 plus root 3 over 3 all over 3 plus root 3 over 3. Now we have a fraction at the top divided by a fraction at the bottom. So in order to simplify that, we're going to multiply by the reciprocal of the denominator. So it'd be 3 over 3 plus root 3. The 3's would cancel out, and we're left with just negative 3 plus root 3 over 3 plus root 3. Okay, and that would be the equation for tan of negative 5 pi over 12. That would be the exact value equation. Okay. Again, this will take some time. You will need to practice this a bit more. And that was one style. So now let's go on to the second kind of questions, which is where you are given the entire equation and you need to simplify it back to what the original function would be. So here we have cosine of 7 pi over 12 and cosine of 5 pi over 12. The first thing that I'm going to recognize is that it's cosine cosine plus sine sine, which means it's cosine of A minus B. If we go back up here, cosine, sine is a cosine trait. It's a trait of the cosine compound angle formulas. And when it's a plus in between, it becomes minus. So cosine plus sine would be cos A minus B. And if we write it in the way that, so that it's written in this way, A is 7 pi over 12 minus 5 pi over 12. And all that's left to do there is to combine this. 7 pi minus 5 pi is 2 pi over 12. And my equation would simply be pi over 6. Cosine of pi over 6 is, again, special triangles. So cosine of pi over 6 is root 3 over 2. And that would be the solution to this entire question. Let's do the same thing for B. In this case, we have sine 2x cos x minus cos 2x sine x. Sine cos in this case is going to be sine of A and B. All we have to figure out is if it's a plus or a minus, remembering that when you have sine of A plus B, then it stays as a plus. When you have sine of A minus B, it stays as a minus. So in this case, the equation shows sine 2x cos x minus cos 2x sine x. So it's a minus in between here as well. Let's write our equation. Let's write our equation down here. This will be sine of 2x minus x, which means it's sine of x. And we don't need to solve any further. Our initial question has an x in it. Therefore, to have an x in your final answer is perfectly fine. And that's how you're going to be applying the compound angle formulas. It's important to get some practice in because these questions can become a little bit complex because of how many fractions there are, and the square root